In this video, we are going to see about error coefficients. Actually, when a control system is excited with standard input signal, we know standard input signals are step input, ramp input, parabolic input. When we excite control system with standard inputs, we will get the steady state error in terms of 0 or constant value or infinity. Among these three, we will get one value. Suppose for any type of system with one standard input signal, if we get constant value of steady state error, so that is the error coefficient for that particular type system. For example, here for type 0, for step input we will get the constant steady state error. Suppose for type 0 system, if we apply ramp or velocity input signal, means we may get 0 or infinity, but we cannot get constant steady state error. According to the definition, for type 0 system, when we give step input, we will get a constant steady state error. So this is the coefficient. Similarly, for type 1 system, if the input is ramp or velocity signal, you will get the constant steady state error. Suppose for the type 1 system, if we give step input or parabolic input, definitely it will give 0 or infinity value, but it will not give constant value. When we get the constant steady state error for a particular type system, by using any one standard input, that particular constant steady state error is the corresponding error coefficient for this particular type system. Next, for type 2 system, if input is parabolic or acceleration signal, we will get the constant steady state error. So which is the corresponding error coefficient? Suppose for type 2 system, if we apply step input or ramp input, we will not get constant steady state error. But for type 2 system, when we apply parabolic or acceleration signal, we will get constant steady state error. So we can say for type 0 with step input, corresponding constant steady state error or positional error constant, Kp equal to limit s tends to 0 g of s into h of s. Next, for type 1 system, when we apply ramp or velocity signal, we can say it is a velocity error constant, that is Kv equal to limit s tends to 0 s into g of s into h of s. For type 2 system, when we apply parabolic or acceleration signal, that corresponding error coefficient is acceleration error constant, Ka equal to limit s tends to 0 s square into g of s into h of s. So here Kp, Kv, Ka are static error coefficients of type 0, type 1, type 2 system. For type 1 system, with step input is positional error constant. For type 1 system, velocity or ramp signal as input, that corresponding steady state error coefficient is velocity error constant. Suppose for type 2 system, when the input is parabolic or acceleration signal, the corresponding error coefficient is acceleration error coefficient, Ka equal to limit s tends to 0 s square into g of s into h of s. Therefore, Kp, Kv, Ka are static error coefficients of a particular system.